Bismillahirrahmanirrahim. Class 12th physics topic Coulomb's law. Our today's topic is Coulomb's law. According to this law, the force of interaction between any 2-point positive charges, let us take 2-point charges Q1 and Q2. These two charges are separated by a distance r. The distance between these two charges is r. According to this law, according to Coulomb's law, the force of interaction between these two charges, Q1 and Q2, is directly proportional to the magnitude of the charges. The force of interaction between these two charges, Q1 and Q2, is directly proportional to the product of their magnitude. F is directly proportional to Q1 and Q2. Product of their magnitude, Q1 multiplied by Q2. And is inversely proportional. And next is the force is inversely proportional to the square of distance between them. So we can say it is inversely proportional to this square of distance, or we can say F is inversely proportional to the square of the distance between them. Okay. If we combining these two relations, this F is proportional to Q1, Q2 divided by R square. F is proportional to Q1, Q2 divided by R square. According to Coulomb's law, this force of interaction is directly proportional to the product of charges and is inversely proportional to the square of distance between them. So we can change, let this F is proportional to Q1, Q2 divided by R square. We can take it F is equal to Q1, Q2 bata R square. What is this? K is a constant of proportionality known as Hoover's constant. K is a constant of proportionality. This K takes value of the system in which we are measuring the quantities, this F, Q and R. Whether we measure it in a CGS system or in a SI system, the value of the K depends upon which system we may use. Whether we take CGS system or SI system. In CGS system, when we are measuring in CGS system, this force, charge and this distance R, then this K takes value 1. When we are measuring these terms in a CGS system, then this K takes the value what? K takes the value 1. Okay. When we are taking this K, we are taking these terms F, Q, R in an SI system, then the value of this K becomes in SI system, value of K becomes K is 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. What is the epsilon naught? Epsilon naught is the permittivity of free space, permittivity of charge in the free space. Is called absolute electrical permittivity. As this epsilon naught is called absolute electrical permittivity of free space when the charges are taken in vacuum. We take this epsilon naught is called absolute electrical permittivity. The value of this epsilon naught is equal to 8.8.854 into 10 raised to power minus 12 coulomb square per Newton meter square. Or in other words, we can write it 8.854 to 10 raised to power minus 12 coulomb square Newton this inverse meter minus 2. Okay, it's the value of this epsilon naught. After finding the value, we can find the value like, for example, if we are taking this F force, we know that the force is directly proportional Q1 Q2 by R square. Instead of F, we can write K Q1 Q2 by R square. Instead of K, we can write F is equal to 1 by 4 by epsilon naught Q1 Q2 by R square. Okay, it is in SI systems. If we multiply it, this to this, then it becomes F into 4 pi epsilon naught R square is equal to Q1 Q2. Okay, we are finding this epsilon naught. Epsilon naught would be Q1 Q2 divided by this 4 pi into this F into this R square. Okay, so after calculating, we have found this, its value is 8.854 into 10 raised to power minus 12 coulomb square is for this C square. After this, we have given the value of 4 pi 24 22 by 7, and after that calculating, we have got this value. Is in the for this we have got this coulomb square divided by this new for force we have Newton, for this distance we have meter square, coulomb square Newton meter square, or we can say 8.854 into 10 to the power minus 12 coulomb square Newton inverse meter minus 2 is the value of this epsilon. Absolute electrical permittivity of free space. So we got the relation on the force of attraction between the two bodies in vacuum, and also we know the value of K depends on the units in which we measure F, Q and R. In CGS system, K was 1. In SI system, in vacuum SI system, K was 1 by 4 pi epsilon naught, and we have found the value of epsilon naught. Note, here we must note the value of epsilon naught. It was the value of epsilon naught in air, which we have found. Now value of epsilon naught in air. Value of epsilon naught in air. That was vacuum. Now it is in air. It is equal to 1.005 epsilon naught in vacuum. That means in air the value of epsilon naught is more than that of a vacuum. We multiply it by this factor 1.005 to the value of what value in vacuum. That means epsilon naught in air would be equal to 1.005 multiplied by 8.854 into 10 raised to power minus 12 coulomb square per Newton inverse and meter minus 2. It is multiplied by this factor. So we can say when this it was in vacuum, it was lesser than that of air. In air it is lesser than and that air it is lesser than that of a liquid. So and so far we have found this force of interaction between any two charges. Inshallah, tomorrow we will take the vector notation of Columbus law. Thanks.